Hi, I'm Sara Barsotti, Coordinator for Volcanic Hazards at the Icelandic Meteorological Office, which is also the Volcano Observatory in Iceland. Between 2018 and 2021, I had the responsibility of coordinating a task within the European project Eurovolc, dedicated to build an international catalogue of volcanoes. So colleagues from Norway, the Netherlands, Greece, Italy, France, Spain, Portugal and the UK contributed by providing information for those volcanoes they are responsible for. The result of this work is the European Catalogue of Volcanoes that I'm going to introduce you today. The catalogue is accessible to the link volcanoes.eurovolc.eu, and it shares the style and structure of the Icelandic Catalogue of Volcanoes that you can learn more in the video by Ríkey Júlíusdóttir. The main purpose of the catalogue is to provide information about volcanoes harmonized between countries and accessible to a wide community that is not only scientists and researchers, but also the general public, students, civil protections and more. The landing page shows an extended map of Europe, where the flags denote the position of those volcanoes for which volcano observatories in Europe are responsible in terms of monitoring and surveillance. It is possible to zoom in and out in order to focus more on those areas we are interested in. On the right, there is a general introduction about the catalogue in terms of its policies and its purpose. And on the left, there are the two main search criteria, by volcano and by eruption. I'll start first with the volcano search. So here on the left, the user finds an ordered list of those volcanoes currently available in the catalogue. It is possible to select by country or by alphabetical order or by the last eruption. By clicking on a volcano, and here I'm choosing, for example, the Berenberg volcano in Norway, the map will automatically zoom on the volcano position and provide some basic information like in which country it is, its last eruption, and the Smithsonian ID number, which is a unique number which identifies this specific volcano. By clicking on Catalogue information, a new window will pop up on the right by showing the chapter which contains information on this volcano. All volcanoes that are currently in the European Catalogue of Volcanoes share the same structure and the information provided through a similar template. So here we can see who are the authors. We see also that it is possible to download the information as a PDF. And also we see, and this is one of the key things of this catalogue, that this chapter is also available in the original language. So for example, here, if I click on Norwegian, then the catalogue will also appear available to the user in the original language. Then a concise information is provided when clicking on the central volcano, where coordinates, the eruptive styles, eruption characteristics, the main hazards are provided at a glance. A much deeper and extended description is available when selecting Detailed Description. 14 subchapters are in common for all volcanoes, and the reader can find information on different topics, including geology, the plumbing system, eruption history, precursors, erupt material, hazards, and so on. Most importantly, a list of references is also available for those who want to learn more. The amount of information depends from volcano to volcano. Specifically for some of them, and here I'm taking the Grímsvötn in Iceland as an example, there are extra chapters available, one referring to the event tree and one on the map layers. Under event tree, then it is possible to get access to a graphical representation of the possible behavior of the volcano since its restless condition until which type of eruption it might feature until eventually the hazards that could be produced in case of an eruption. Under map layers, it is possible to visualize information which are geographically referenced. So for example, we could choose to visualize the extension of the tephra fallout during the eruption in 2004, and we can see how it has been mapped on the ground by the volcanologist, which has been the extension on the ground of the tephra fallout, what we call the isopachs. But we can also visualize, which has been the extension of lavas that has been featured by previous eruptions in Grímsvötn. And we can also then visualize the extension of the fissure system of the central volcano and the caldera. The other search option is the eruption search. The search can be done via several keywords or parameters, but in general the query is done by looking into the database, which includes eruption for volcanoes in Europe. Here we can see the list of all those countries. So if we select Iceland and then we click on search, then a list appears on the right. This table summarizes the key information about these eruptions. And if I scroll down, I can select the Eyjafjallajökull, which is a quite famous eruption that occurred in 2010. And if I click on this line of this table, then I can find more detailed information. Specifically, a new table pops up. And there are quantitative information like the starting time, its duration, volumes, but even information in terms of impact, damages or fatalities. Most importantly, at this stage, for some of these eruptions, there is additional information regarding observations that have been done during the eruption. So if I click on this link and I open this link, then I will have access to additional amount of information about the available data that have been collected during that event. So specifically, the users, they can search for metadata and finding which type of measurements and observation have been done, where these data have been published, if it is possible to access them, if it is possible to ask for them, and where to find them. The catalogue offers also an overview in terms of potential volcanic eruption impact on the aviation. Up here, there is an icon representing an airplane. And by clicking on it, we can download what is called the aviation table. This table summarizes some key information regarding volcanoes within the aviation community. So, for example, there is the name, the ICAO code, the coordinates in a format which is the standard within the aviation community. And then there is also the most likely vertical limits in terms of plume height and the reasonable worst-case scenario, which in a way identifies the highest plume height we might expect from these volcanoes. So in restless condition for VACs in Europe and in the world, it is essential to have scenarios to use for running their dispersal simulations. This table then represents an initial scenario designed on what historically has been observed at these volcanoes and gives then a best guess on what might be in the future. The European Catalogue of Volcanoes is a window on what is known about volcanoes monitored by European volcano observatories. In this sense, it is a first step towards an harmonized and consistent way of providing information about volcanoes. More work is expected to be done in the future within the European volcanological community to extend the content of the catalogue and make it a key source of information for all those who want to learn more about volcanoes and their activity. We hope you enjoy it, and thanks for watching.